everyone, I am Nandan Roy from Center for Theoretical Physics and Natural Philosophy, Mahidol University. Today we will be, in this video today we will be discussing about very elementary of differential equation. So let us first discuss what is differential equation. Differential equation is a mathematical equation which connects variables to its derivative, and so what does it mean? It means, so suppose there is a variable which is y and it is a function of x, and there could be derivative of y which looks like dy by dx, and you can have more higher order derivatives of dy by dx to the power n. So a equation which consists of, which is a function of some d n y by dx to the power n, and y is actually a differential equation. Now there are two main classes of differential equation. One is ordinary differential equation, and ordinary differential equation is of the form where there is only one independent variable. And for a partial differential equation PDE, there is more than one independent variable. So that means a differential equation of this form dy by dx equal to f of x y. F of x y is a ordinary differential equation, and if you have some derivative which is a differential equation, suppose I just take del 2y by del x2 plus some del 2y by del z2 equal to some function of x, y and j, then it is a partial differential equation. And in this video we will be focusing on mostly ordinary differential equation where there is only one independent variable. So there are two important terminologies in differential equation. One is order and another is degree. So order of a differential equation is the highest order derivative present in the differential equation. So suppose I have a differential equation which looks like d2y by dx cube plus 2 d2y dx2 whole square plus dy by dx equal to some f of x y. So this is, suppose, our example differential equation. The order of the differential equation is equivalent to the highest order derivative involved in the differential equation, and the degree is the power of the highest order derivative. For here the highest order derivative is 3, but as you notice this is highest order, the highest power is 2, but it is associated with the second order derivative, so we cannot count it. We will count the degree for the power of the highest order derivative. So this is a third order but first degree differential equation. Now differential equation can be linear and non-linear. So what is a linear what is the definition of a linear differential? Suppose we have a differential equation which looks like this. It's a very general form of a differential equation. So, if this differential equation looks like this, so that the first criteria these to be linear is dependent variable and the dependent variable and the derivatives and all derivatives have power 1. So, there is no higher power for this, and there is no cross term here. And the second is that this a n x and the g n x and g n x are either constant or function of independent variable. So, this is the criteria for a differential equation to be linear. So, suppose we have a differential equation which looks like this. So, this is a linear differential equation, but if I consider this one, d2y by dx2 plus 4x dy by dx equal to sin y. Now you see this is g, this is a function of y. So, this is a nonlinear differential equation. So, let us try to find few methods for solving first order equation, differential equation. So, in this video we will be only solving the first order differential equation, not solving any higher order. Maybe in some next video we will be doing that. So, a first order differential equation is generally written in this form: di by dx equal to f of x and y. Now, the method which is called variable separation. So, how does this method work? So, if you have to look at your differential equation, because each depending on the differential equations you will have to adopt different methods to solve it. Suppose you see your differential equation, it looks like this: f of x and g of y. So, in this case this you can apply. So, this is a multiplicative function of x and y. In this case you can apply the variable separation method. So, how does it work? So, the trick is you have to put everything y and x in the two sides. So, suppose how we do it. So, we put it g of y dy equal to f of x dx. Now, what you have to do to solve it? Just integrate it, that is all. So, let us take an example for solving this equation. Suppose we consider this differential equation. So, as you can see, this can be written as So, again use the same method, dy by 1 plus y square equal to minus dx x dx by 1 plus x square, and if you do that and if you integrate it, this is a tan inverse y equal to half ln 1 plus x square plus c, and then you can see the y is tan of. So, this is you can write as ln c as a constant ln c by square root of 1 plus x square. So, this is one example, and this method is called the variable separation method. Okay, the next method we will discuss is basically homogeneous equation, solving homogeneous equation. So how this differential equation looks? So suppose you have dy by dx equal to f of xy. Now if you see your f of xy looks like that it is a ratio of two functions g and a, and if you take this x to the power n and phi to the, and you can write this to be y by x, and I will give an example for this, and x to the power n to be some eta y by x, then you can say this is a homogeneous differential equation. Okay. And what is the step for solving this differential equation? The step for solving this kind of differential equation is you have to write, first one is you have to write dy by dx as the function of some g which is y by x. Now what you do, you take u equal to y by x, u, or sometimes people take it v, whatever you want, and then transform the whole differential equation in terms of v and solve it. Maybe I give an example which will help us to understand this type of equation. So as you can see, this is like this equation I can write dy by dx is x square plus y square by 2 dot x y. So I can take x square outside and check if it is a, so if I take 1 by y by x, and then again if I take x square out, 2 y by x. So this is eventually on this form. So this is a homogeneous equation. So why I consider is, then next I consider y is vx, or v is y by x is same. So now I have dy by dx is actually v plus x dv by dx. So I find out dy by dx. Now I put dy by dx. I have this differential equation, so I put dy by dx from here. So it will be v plus x into dv by dx, and this side is going to be 1 plus v by 2v. Okay, and then I take this v that side, and it will become x dv by dx if I write, and it will be 1 minus v square by 2v. And now if you use the method of separation, variable separation, which we used before, you will find the solution of this is x is 1 minus v square. It's very easy to find. I leave it for the viewers to check, and this is, now you put the v is y square by x square. So the final equation solution will be y square x square minus y square equal to cx. Okay, so this is the solution and using the homogeneous equation method. And now if you have a simple inhomogeneous equation, you can change it to a homogeneous equation and solve and apply this technique to solve it. So suppose I have this differential equation which like dy by dx equal to ax plus by plus c and fx plus gy plus e. Now if you see, if I take x outside, this will be this will be looks like x this will be looks like 1 plus a plus b into y by x plus c by x, and this will be x f plus g y by x plus e by x. So now this equation is inhomogeneous because of these two terms. So if we find a transformation of x y so that these two terms become 0 in any new using a new transformation, then we could use this this form of differential equation to be to use by the homogeneous method. Suppose I just give a very simple example. Dy by dx is x plus y plus 3 and x minus y plus 3. So the technique here is you choose a different x. So this is so I choose a big X, which is this small x plus h. So I write it small x, and capital Y is small y plus maybe k. So you put it here. So your dy capital by dx is going to be x plus y plus h plus k plus 3 and x minus y plus h minus k minus 5. So now if you make these two equations to be 0, then you can have a homogeneous equation. So make these two 0 and solve this h k plus 3 equal to 0, h minus k minus this should be 5, not 3. So this should be minus 5. Yes. So this is equal to 0. So when you solve this, you will find h equal to 1 and k equal to minus 4, and this now you know this transformation for this case. So you have to put x plus 1 and y minus 4. So if you do it, then you will arrive at this differential equation in terms of this capital X, x plus y by x minus y. So then it's a homogeneous differential equation. You can use this the technique I described before. Okay. So next technique I would like to discuss is called exact differential equations. So suppose you have a differential equation which is of this form. Dy by dx is f of x y, and which is of this form p x y q x y. Then you can write q x y dy equal to plus p x y dx equal to 0. And suppose you have a function which is function of x and y u. So when you take du, total derivative of it, del u x y and del x into dx plus del u del y into dy. So if this is the total derivative of this function, so Now, if we make this function to be 0, we consider this to be a total derivative. So, you will get a condition on this. So, that is why it is called exact differential equation. So, you will get q yes, q is p, just a moment. Q is dy, yes. So, q is with dy, so q is del u by del y, and p is del u by del x. So, this is, if this is a differential equation, so then u, the function u x y equal to c, the constant, is a solution of this differential equation. And how do you check our differential equation is exact? So, you have to take del p by del y, which is del u by del 2u by del x, del y del x equal to del 2u by del x del y equal to del q by del x. Let me give an example to you. So, suppose I have this differential equation. So, 4x cube plus 6xy plus y square equal to dx by dy minus equal to minus 3 x square plus 2xy plus 2. So, now you have to check this is 4x cube plus 6xy plus y square with the dx plus 3x square plus 2xy plus 2 into dy equal to 0. So, what is your p now? So, you can see p is with x, p is with dx. So, p is 4x cube 6xy plus y square, and q is 3x square plus 2xy plus 2. So, you got the del p and q. Now, you check if del p by del y is equal to del p del q by del x, and if you check it, you will see del p by del y is 6x plus 2y, and this is del p by, so it is also 6x plus 2, yeah, 6x plus 2y. Okay, so this is an exact differential equation. So, what will be the solution for it? So, what will be the solution for it? The solution for it is, so how do you find it? You know, phi is del u by del x. So, del p is given to you. This is 4x cube plus 6xy plus y square. Now, if you solve it for u, you will get, so this is the x to the power 4 plus 3x square y and plus x y square, and this could be a function of y. So, there could be a function of y that side, which make the partial derivative to be p, and then if this is the u, then it should satisfy the form of q. So, del u by del y, this should gives you the q. Which q? This q. So, if you take derivative of this, what you will get? This is 0. So, this is 3x square plus 2x plus del phi by del y, because this is a function of y, and it has to be equal to this q. So, this is 3x square plus 6xy plus 6. So, if this is the case, you can cancel this, and what you have, I might have a mistake, so this 3 should go here. Yes, sorry. Otherwise, it won't make it an exact differential equation. So if this goes there, so you can see this will be 2, so you can cut it to 2x because its derivative with respect to y, 2xy. Yeah, this should be also y. So this should be y. So it is cancelled. So what you have is this will be 2 also because this is 3, this is 2. Okay. So you have del phi by del y equal to 2. So phi is going to be 2y plus c, and then the u you have is going to be your solution. What is the u you got here? Put the phi back, so you will get the, so u is going to be x to the power 4 plus 3 x square y plus x y square plus 2y plus c. So this is the solution for the differential equation. Next, I would like to discuss another method which is called method of particular integral. No, sorry, this is called integrating factor. So suppose you have an equation which is like this, dy by dx plus p, this could be function of xy also, dp y equal to qx. This is the form of the differential equation. Then you can find a factor, what is ix, it looks like e to the power px and dx, and you can multiply both sides of this differential equation to be by e to the power px dx. You can multiply ix to this differential equation, and it will be, suppose this will become px dx and dy by dx plus px e to the power px dx into y equal to e to the power px dx into qx. So if this one is this and this is ix, so you can write this equation as actually d dx of ix into y equal to q into ix, because this is your ix, the integrating factor. So now this is a, you take this dx to this side, so it is q is also function of x, so you can solve this differential equation easily. So let us have an example for this. So suppose I have a differential equation which looks like dy by dx y cos of x equal to half sine of 2x. So what will be my integrating factor is exponential of, so why is p here? P is here is cos x, so it will be p x dx, so it is e to the power cos x dx, and it is going to be e to the power sine x. So now you find this factor, this multiply both sides with this factor, you multiply both sides with sine x dy by dx plus y cos x e to the power sine x equal to half sine 2x e to the power sine x. So, now if you see it, this becomes a dx of y e to the power sine x, and this side becomes half sine 2x e to the power sine x. Now, this differential equation is easy to integrate. Y e to the power sine x equal to, this will be sine x e to the power sine x and cos x, and we have to integrate with this, so, and there will be a constant c. Now, you can put it as a, you can solve it by considering this is a, I leave it to the viewer to solve this one. This is a very standard different integration to solve, and if you solve it, you will find the form of the solution is sine x into sine x minus 1 plus c. So, the thing is that if you consider sine x to be z, the trick is here sine x to be z. So, dz by dx is cos x, so this term, and this will be a z e to the power z into dz. This will be the differential equation. So, integration you have to find out. So, it is very easy. I leave it to the viewer, and this y is actually sin x minus 1, then sin x minus 1 plus c e to the power minus sin x. So, this is the solution, and there are a couple of other methods by which we can solve the first order differential equation, and in some future videos we will be discussing about higher order differential equation, order higher than the first order differential equation. So, for this video, this is what we want to discuss, and see you in the next video.